Hello, Assalamualaikum, and good afternoon to everyone. Today, our group will be presenting on BGP case study. Next. Okay, so my name is Muhammad Azim bin Azmi, and my matrix number is 223796. And in my team also, we have Theo, um, Sujan, Zaki, and Aiman. Next. So, we start with what is BGP? BGP or Border Gateway Protocol is an external protocol that is used for routing between autonomous system. It facilitates the communication and routing between AS to ensure seamless connection between large networks. BGP is a path vector protocol which checks the full packet route instead of just checking the destination of the packet just from looking to the AS number. So instead of taking the shortest path, BGP is more focused towards routing based on certain policies and control. This makes BGP very good when it comes to routing a packet based on the policies and the control that is given. As such, it is a policy-driven nature that allows high flexibility when it comes to configuring the network. So network admin can easily configure on what policy and what control that it can give to the packet and what kind of network can goes in and out of the certain system. I will pass to my next person.
So thank you so much, Azim. So okay, let us dive into the when is BGP used. Got a lot of applications and when BGP used, but I chosen four. I chosen five main things. So first thing, BGP used when multi homing and redundancy time. So BGP enable multi homing, like allowing a network to connect to multiple ISPs for redundancy and high availability. Okay, this is so essential and crucial to institution like universities like us, UPM, for example, and finance organization that cannot afford internet outage. And if one of the ISP fails, this BGP will reroute the traffic instantly to another ISP, ensuring continuous uptime. It won't. It makes sure no lagging, so continuous uptime and reliability. So the next thing is traffic engineering and path control. BGP is used in traffic engineering and path control. Like besides redundancy, BGP is widely used in it, allowing control data flow based on the performance, cost, and policies. So unlike basic routing protocols, BGP let administrators like okay, the administrators choose preferred ISPs, control inbounding and also outbounding traffic between it, and balance load across the link. So this is so flexible to enable the BGP attributes like local, brief, met, and as path, preventing like premium ISPs for customer traffic and cheaper links for backups. So next slide. Okay, the next one is scalability for the large organization and data centers. So BGP is essential for organizations like networks spanning multiple regions or data centers. Okay, let us take example as Google. Google got a lot of data centers, right? So it is commonly used for large enterprises like cloud providers, CNDs to manage their interconnections across geographical distributed sites or internet exchanges. So BGP ensures consistent, efficient routing and centralized policies control no matter where the router is used or located. And then the fourth thing is BGP used when it in internet backbone and cloud environments. So how is it possible? Like BGP used in ISPs on public internet and to exchange routers and advertise reachable IP preference. Like without BGP, cross-border and inter-provide routing would not be structured or scalable. So cloud provide like AWS, Google Cloud, and Azure uses BGP pairing with customer network to enable dynamic routings like dynamic routings, failover, and scalable cloud connections. For the last one, next slide. Okay, the last one is when a BGP used when it's a disaster recovery and failover planning. So BGP support disasters recovery by enable traffic redirection during regional outage throughout multiple sessions with ISPs or data centers in different locations. This setup ensure automatic failover to secondary or tertiary sites, maintaining service available. BGP is vital for business continuous in mission critical sessions like banking, healthcare, and also e-commercials. So thank you so much. I pass to my next member.
Thank you, thank you, James. So now I'll be explaining where BGP is commonly used in real-world networks. So the first is the public internet or between autonomous systems. First, BGP plays a crucial role in the public internet. It connects different autonomous systems or AS. These AS are essentially large independent networks such as internet service providers, large enterprise, universities, and government networks. BGP is responsible for ensuring data that can be routed efficiently across the system, even when they span across countries and continents. It finds the best spot for data to travel across the internet. For example, in Malaysia, ISP like TM, Maxis, Celcom Digi, and Time rely on BGP to handle both local and international routing. Globally, major ISPs such as AT&T, Verizon, and Google Fiber use BGP to manage routing and form the backbone of the internet itself. The second point is for large enterprise and campus network. This is for multi-home connectivity. BGP is also widely used in large enterprise and campus networks, especially when organizations are connected to more than one ISP. This is called multi-homing, and it helps ensure redundancy and load balancing. That way, if one connection fails, the other can take over. Enterprise can also use BGP to advertise their IP prefixes and decide the best traffic path. It allows them to implement routing policies based on their goal, whether that's best performance, lowest cost, or security. This is especially helpful for multinational companies that need to manage inter-office traffic across different regions or continents. Next slide. So the third point is the cloud network and hybrid environment. BGP connects data centers and customer networks in cloud and hybrid setup. It used in VPNs and dedicated links like AWS Direct Connect or Azure Express Route. BGP auto advertise prefixes and select paths between on availability and policies. It also critical for high availability businesses like banks, e-commerce, streaming services. Last, for where is BGP used is in the government and education institutions. Government, universities, and research institutes use BGP to manage their own network. BGP helps maintain redundancy and policy-based routing across multiple ISP links. It ensures uninterrupted service like research traffic and online learning, even if one link fails. So that's all for me. I pass to the next question.
Okay. Who use BGP? Okay. Mostly ISP use BGP to exchange routing information between different networks. In Malaysia example, it's Maxis, Celcom, U-Mobile. Also, large enterprise with multiple internet connection use BGP for redundancy and load balancing. For example, Petronas. Also, data center and cloud provider use BGP to connect with multiple network and ensure high availability, such as Google Cloud. Also, content delivery network CDNS and tech company use BGP to efficiently route traffic to user worldwide, such as Maxis CDN. Okay, in summary, BGP is used by any organization that manage multiple networks or connection to the internet.
Thank you, Zaki. Moving on with me. Sorry, my camera doesn't work, so my I don't have a webcam, so this is my camera. So moving on, how does the BGP works? So BGP works with TCP with using port 179. That is to send information between routers. This to make sure data is sent reliably. Routers using BGP are called BGP peers or neighbors, and there are two types of BGP, internal BGP and external BGP. What's the difference? Internal BGP is when the routers are in the same autonomous system. External BGP when routers are in different autonomous system. Before routers can talk to each other using BGP, they must be manually set up to become peers. Once set up, they create a TCP connection and send messages like open, update, keep alive, and notification. What are they? Open is to start connection. Update is to share routes. Keep alive is to check the connection is still working. Notification is to report any errors. Next slide, please. Okay, what makes BGP special? BGP, as mentioned with Azib in the first slide, BGP is a policy-based routing protocol, so it doesn't just look for the shortest or fastest path. Instead, it uses route attributes to pick the best path based on the rules that is set by network admins. Some important BGPs are attributes are ASPAT, next hop, lookup, pref, which is local preference, med, multi-exit discriminator, and origin. What is ASPath? List as the autonomous system route pass through helps avoid loops. If a router sees its own autonomous system in the list, it will reject the route. Next hop. What is that? The IP address of the next router to send data to. Local preference used inside one autonomous system. Higher value, which means better route. Next one is multi-exit discriminator, suggests a preferred entry point into a network from another autonomous system. Lower value means better. And origin is to tell how unknown. Next slide. Okay, how does BGP choose the best route? When BGP has multiple options to reach the same place, it compares them using a priority list. What are they? First, prefer higher local preference. Second, prefer shorter as fast. Third, prefer lower multi-exit discriminator. Fourth, and other rules if needed. This way, BGP picks the route that follows the admin's, businesses, and technical rules, not just the fastest path. Next, why is BGP important? Because it prevents loops. BGP avoids routing loops using as path. This keeps the internet stable, scalable. It can handle hundreds of thousands of routes, which is why it's used by big ISPs and companies. Flexible. BGP allows fine control of traffic, so it's also used in cloud platform like AWS or Azure and in data centers. In summary, BGP is like a traffic control system of the internet. It helps networks talk to each other, avoid loops, and follow smart rules, not just source path, because it's stable, powerful, and flexible. It's trusted to manage internet traffic all over the world. Thank you. That's my part. Moving on with Azul.
All right. So thank you, Phil, for that. And now I will be talking about a simple BGP topology. This is a topology that I've created in ENSP. So in general, as you can see, there's the first router one that is connected to the internet and have its own autonomous system. And then it is connected to R2 that is on its own autonomous system, which also in there have R3 and R4. So the only way for the R2 to go to the internet is through R1, which is a different AS. Okay, so next. All right, so this is what the configuration for the BGP. This is on, I will only talk about router 1 and router 2. So this router 1 is running the BGP with its ID of 65008 with the router ID of 1.1.1.1. We have a peer to 200.1.1.1 as number is 65009, which is the BGP for R2. And then this IPv4 family unicast is used to broadcast the IP address to other router, which in this case is R2. So this is the R2 BGP, which is the 65009 with the router ID of 2222. It has three peers, which is, as you've seen before, connects to R1, R3, and R4. And this is the IP address for R2, R3, and R4. This is IP address for R1, which have the BGP number here is 65008, unlike the router 3 and router 4, which is 65009. And of course, there's the IPv4 family unicast, which is to broadcast its IP to the R1, which also have the peer, the three different IP addresses as their peer. Okay, next. Alright, so this is the showcase for the BGP routing table to show that the BGP does work, which shows R1 that there is a total four routes in total, which is the 9.1.1.0, which is R3, and 9.1.3.0, which is R4, and the 200.1.1.1.0, which is R2. As you can see here, all of them are in the routing table. And also, this is display PGP peer, which shows that our peer is just 200.1.1.1, which is R2. Okay, next. So this is the R2 BGP routing table, which as you can see here, there's nine different routes. Most of them are just peers. And the 8.0.0.0 is the internet, which you can see it has the next hopping address of 200.1.1.2, which is router 1. And the pair here showcase that this is from Autonomous System 65008 internal, which meaning that the BGP does work and it does have the AS of 65008. And for BGP peer, you can see that the peer is router 3 and router 4 and router 1. And all of them are established with the autonomous system listed as follows. All right, next. All right, this is to showcase that R1 can connect can ping R4, which is on the different side, which is on a different autonomous system. We can see that all of the packet has been sent and actually got the reply from, which meaning the connection is actually exists and it does connect from R1 to R4. Same with R4 to R1. Okay. Next, that should be all. All right, so that's all for our group presentation today. Thank you for listening and yeah, thank you.